Okay, welcome to day 7 of Intro to Object-Oriented Programming. We are going to take a break from learning new concepts today to answer a question. I like to answer questions when they finally do come in. So one of you people watching Intro to Object-Oriented Programming sent me a question on Thursday or Friday last week that was basically this. I understand how to use the access modifiers, but I don't know why I should. For example, why would I use public instead of just putting internal on everything? And I thought this was a very insightful question. When is it appropriate to use public or private or internal or so forth? Okay, so today I'd like to answer that question with a very long-winded answer by writing a little app. Okay. One of the aims of object-oriented programming is code reuse, okay? Or in other words, I build some code and tens of thousands of people can reuse it easily. One of the aims of encapsulation is making that code reuse easy, okay? Or in other words, exposing the important details, hiding the unimportant details, okay? So what I'd like to do today is build an app that requires an outputter, okay? We're going to build 2 different projects today. The first project will be called outputter or something like that, and it will be responsible for all the operations of outputting stuff, okay? It might output to the screen, it might output to a file, we don't know. It might output to a database. Okay, our second app is going to use the outputter to do its functions, okay? It's going to be an accounting program, and basically an accountant is going to punch in a bunch of numbers, and the outputter will help capture those numbers, okay? So let's go ahead and start. First off, I've got Visual Studio 2017 open. The reason I'm doing that is today I'm working with the .NET framework instead of .NET Core, and that's because when using the .NET framework, we can generate what's called a DLL, all right? And the DLL is basically, you could just call it a redistributable software package, okay? So very first, I'm going to create a project called World's Best Outputter. And notice I've used .NET Framework, version 4.6.1. Okay, I'll go ahead and create this project. I'm going to rename my class file here to be outputter, and I am going to rename the class as well. Okay, very good. So you notice here that we've got a public class, okay? And we've also got a public method. Okay, so very descriptive names here. Fix my formatting. Okay, all this is going to do for now is log out to the console. Okay, very good. So this is a very simple class. This is something we've done probably 100 times between Intro to C# and Intro to Object-Oriented. I'm going to go ahead and build this project. Build the solution. It will build all the projects in the solution. Okay, now if we go to this directory, we should be able to see the DLL that was generated. So I'm going to go to C, Users, B. Davidson Source, Repos, World's Best Outputter, and we'll dive into the bin folder, and there, inside of the debug directory, not the release directory, we should see World's Best Outputter.dll. Okay, we've created our reusable software component. It's very simple at this time. One class with one method, but now let's go ahead and reuse that, or use it, in a new application. So I'm going to open up a separate instance of Visual Studio 2017 here. Okay, and I'm going to do a new project. This time I'm going to create a console app with the .NET framework using version 4.6.1. Okay, and finally I'm going to call this accounting software. Creates our project. I'll rename, let's stick with program. Let's add a new class here. This will just be a plain old C# class, and we'll call it Accounting Manager. I'm no accountant, so if you're an accountant and you're watching this, don't judge me. Okay, let's go ahead and make this class public. Okay, and we're going to give it one simple method, public void do account management. Okay, and we'll make sure that the program.cs does this. Okay, the accounting manager inside of it to start is just going to ask for some simple equations, okay? So let's go ahead and write that up. All right, let's do our first output. So here we need access to the outputter. So we don't have access to it just yet, right? The way we reuse code from other solutions or projects is by adding a reference. I'm going to go ahead and do that here. I'm going to add a reference, and I'm going to click the Browse button, and I'm going to browse to the directory of World's Best Outputter. I'm going to find my DLL or reusable software package. I'm going to select that and add it right here and say OK. Okay, now I should be able to create an object of type outputter. So I'm going to say var outputter is equal to new outputter. Okay, and Visual Studio is saying I need a using statement. I'll go ahead and use World's Best Outputter. Okay, this is my reusable software project here. Okay, now that I have the outputter, I can start doing output. Outputter dot do best output. Enter a number, or let's see, let's ask them, what would you like to do, question mark. And then we'll do it again, outputter, do best output, /t, press A for addition. Plus S for subtraction. Press M for multiplication. D for division. Okay. Go ahead and get their input. Read key, as you'll recall, returns us a console key info, which contains a console key. So then we'll say if input.console.e is equal to console key.a. Then we're going to ask for two numbers. Go ahead and do our final output message for addition. Do some string concatenation. And we'll keep it peppy. Okay, let's go ahead and run our console program. And I'm going to add a console.read key here at the end to make sure that we see the output that we want to see. Builder. Boink, boink. Okay. Something went wrong. All right. Go figure out what happened. Oh, we added the first number twice, or added the first number to the first number instead of adding the second number. Okay, there we go. Small mistakes, everybody, small mistakes. Okay, so this is very similar to programs that we've already written. The only difference really is that the outputter lives in a separate software library. So now I would like to get to the meat of the question. The question was, well, why should I use public versus why should I use internal or private? Okay, and the answer is, when I'm writing software like World's Best Outputter, I need to make the parts that I want people to use, I need to make them public, okay? If they are anything besides public, they will not be visible to users of our software. So, as an example, I'm going to mark this method as internal. I'll go ahead and build to regenerate the DLL. And then I'm going to come over to our accounting software and I will build this. Okay, and you can see that we generate a bunch of errors. Outputter does not contain a definition for do best output and no accessible extension method do best output blah 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 blah. Okay, internal works when you are writing code in a single project, okay, and all of your code that needs to access that code lives in the project. But when I'm building code to be reused, which is one of the tenets of object-oriented programming, I need to make the parts that I want visible public. Okay? Let's go back and fix our error. Okay, now we fixed. We got rid of the old yucky DLL and got this new one that includes do best output. Okay? So you may be asking yourself, well, why would I ever write software in my world's best outputter or a similar type of project that isn't public, right? Why wouldn't I want to allow users of my code to control it completely? Okay, and the answer here is we need to protect our state of our software. Okay, if we can't protect our state, we cannot guarantee stability of our software. Also, by only exposing a percentage of the functionality and only exposing the important details, we can change our implementation, we can add unimportant details, and we can release DLLs without breaking the applications that are using our code. Believe it or not, it happens quite a bit that we are forced to change our application because publishers of external code make breaking changes, and in order to upgrade, we need to and get the new DLL file or reusable software package. We have to go and change our application so that it won't break. Okay, encapsulation protects our internal state and only exposes the important details, hopefully making it easier for the users of our code to reuse. So as an example here, I'm going to add a totally new feature to World's Best Outputter, and I'm going to add a lot of code here to this project, but the users of my code will not necessarily know about that, right? Because I'm only going to keep the do best output method as public, okay? And the change will be this. I want to, for the lifetime of an outputter object, I want to store all of the output that the user output, and then I want to give them the ability to play it back, okay? So in order to achieve this, I'm going to add a constructor. Here's our outputter constructor, okay? And this guy is going to, we're also going to add a property. We're going to call this and we're going to make it private because this is our internal state. We don't want anyone monkeying around with this. Private string builder session logs. Okay, and then our constructor is going to make sure that session logs has been instantiated. Okay, now every time someone calls do best output, I want to add it to our string builder. Very good, okay. And I'm going to add a new feature here. I haven't changed anything about do best output. I haven't added or removed parameters here. It still returns void where users are expecting it to return void, but now I can add a new feature to my software. Okay, and we're going to call this playback session. So basically, it's just going to take all of the logs, all of the output that was output via the outputter, and it's going to play it back. So let's regenerate our reusable software package. And let's make sure that we're using the new software package here in our app. Okay, now I want to make sure that the outputter is accepted here by our account manager so that we guarantee that the playback feature only happens once, okay? So let's get rid of this one. Then let's go fix our problem over here in program, saying, hey, I need to use outputter. We'll have to add a using statement here. Fine. Fix that error first. And now let's add our using. Okay, and finally, once the do account manager has exited, we can now have access to playback session. Notice that we do not have access to the session logs, right? We don't have access to that because we don't want someone in the middle of a session to manipulate the session logs. We want to control access to that. So we've hidden it using our access modifiers. We've said the session logs are private. You, user of the outputter, are not allowed access to the session logs directly. You may have access to them by calling our playback session method. Okay, and in order to achieve this, we just need to make sure that we are respecting the X key. So let's refactor our app a little bit here. Okay, let's add the exit condition. We don't need to add the exit condition because we've already done it here. Let's just tell the user that it's an option. All right, here we go. So let's add 1 and 2. Let's add again 3 and 4. Let's add again 5 and 6. And now let's exit, and I am expecting to see this playback. We didn't get it. So let's go figure out what our problem is here. I'm going to pause while I figure out what's going on. Okay, it was outputting the whole time. It just looks exactly the same as our previous blocks, except for the input here. So it was working the whole time, just working too fast for my tiny brain. Okay, but as you can see here, the session logs, we pressed X, and then all of the logs were dumped out there. The only thing that wasn't captured was the user's input. Okay? So this is a feature that we just added to our software package. We added logging, and the user didn't even have to care. I mean, they came and added a call to output or playback session, right? But we changed the implementation of do best output. We added some private elements here to our software package, and the user is none the wiser. Okay, and this is the beauty of encapsulation. We expose the important details, but we hide the unimportant details, and by hiding the unimportant details, we protect our internal state. Okay, well, I hope that answered the question, and I look forward to hearing more questions from y'all.